In the last section, when we were working with the percent equation, we were looking for the same amount in every problem. That is, here's our percent equation, and in all cases we were looking for the amount. Well, in this section we're going to change the item in the percent equation that we're after. Here we're going to do this kind of thing. What percent? We're going to find percent here. What percent of 50 is 10? And we're going to approach the situation in much the same way. That is, we're going to go from an English sentence into a mathematical sentence, and then we're going to solve that mathematical equation. What percent? We just need a variable to stand for that. Let n stand for that. Of means times. 50 means is equal to 10. And now we'd like to find the value of n that will make this true. Now, we have seen a situation similar to this before, but we're just getting into the notion of solving equations. And for this kind of equation, we are trying to perform a manipulation of some kind that will cause the equation to tell us the value of the letter. We want the equation to read n, or whatever letter, is equal to some number. So we need to isolate the letter on one side of the equation or the other. Now here, in order to isolate n, we need to get rid of the 50. Now notice that it's n times 50, and to remove 50, we can divide on both sides by 50. Now I would like for you well, let's see, how do I encourage you to have a sense for the formality of solving equations and not just looking for an answer? You see, the tendency right here is to learn very quickly what we're going to do and in order to get an answer, and then do that every time and be able to say, well, I get the right answer, why do I need to show that work? You see, that kind of thing. And you show the work and you look at the problem as an equation, and you maintain the integrity of that equation throughout the problem, because problems in mathematics are going to get a good deal more difficult than this. And as problems become more and more difficult, the way you handle them is through greater organizational skills, not through some vast amount of mathematical knowledge. And the organizational skills that I'm talking about have to do with showing all of the work and thinking in terms of concept or the general idea in solving this kind of problem or that kind of problem. So you get high mileage out of that kind of thing when problems get more and more difficult. All right, here's what I mean. Here's how we apply that idea here. We have n times 50 is equal to 10. Now we could write this, by the way, as 50n is equal to 10. That's okay. Putting the 50 on the other side of the n is nothing more than using the commutative property of multiplication. So we could write it like this. Now we'd like to remove this 50 over here. We see that this is 50 times n. The operation, which is the inverse of multiplication, and by inverse it implies that it'll undo it, is division. Division will undo multiplication. So what we'll decide to do is divide by 50 on both sides. Now I say on both sides because we have a statement of equality. We have a balance here of value. We can think of it like that. So what's over here has the same value as what's over there. So if we divide by 50 over here, we need to divide by 50 over there. And that's the way I'd like you to think about it. So let's show that idea. Let's show that we're going to divide over here by 50. And if we do that, we need to show that we divide by 50 on the other side to maintain the balance. The 50s cancel here, leaving n. And on the right, we have 10 over 50. Now, I can divide on both sides by 10 to give us 1/5. And that's fine. But, gee, we were asked to find a percent. It began with what percent of 50 is 10? You see, so we're looking for a percent. So the prudent thing to do is to take that 1/5 and change it into a decimal. 1 divided by 5, you see, go through that process, and we end up with 2/10. And we change 2/10 into a percent, and it turns out to be 20%. Now, in finding n to be 20%, we are answering the original question. We're answering the question, what percent of 50 is 10? We're saying then that 20% of 50 is 10. Here's another one, and we approach it the same way. What percent of 24 is 18? And go through the interpretation process to set up the equation. What percent, some letter, of means times, 24 bring down, is means is equal to, 18. Now we have an equation to be solved. We might want to write n times 24 as 24n. You may not want to put this step in, and it's okay to leave it like this, and then from here divide on both sides by 24 to get that nice convenient cancellation. But here's what we need to show. We need to show that we're going to take the left side of the equation in one of these forms and divide by 24. And if we do that on the left, if we divide by 24 on the left, we need to divide by 24 on the right to maintain the balance of the equation. The 24s go out here as expected. We're left with n. On the right, when we divide 18 by 24, we get 0.75. We change that into a percent form in order to answer the question posed in the problem. All right, so this is the format that we're going through. Here again, what percent of 2.4 is 0.6? What percent n of means times 2.4 is equal to 6/10. And so we have 2.4 times n equals 6/10, and away we go. Now I've stopped right here. We're going to pick up the problem right here because we know that in the past, we divide by the number next to the letter, basically. And that's what we're going to do here. We're going to divide on both sides by 2 4/10. So we're going to show this. Now these will cancel as expected, leaving n. And now we go to the side and perform this operation. 6/10 divided by 2.4. Oh, that's 2.4 into 6/10. So we want to go over here and show this. Now this is an important part of the demonstration of your solution. And I want to call it that. You are demonstrating how to solve this problem and how to solve this equation. And whatever you do to accomplish that task is part of the demonstration of your solution. You see, there's a tendency sometimes on the part of students to scribble this in the margin or something like that, to not show that as though you're proud of it. But you want to show it. It's part of the solution process. And so it needs to be illustrated in some way that's not just scribbled in a margin or something like that. It's part of the demonstration of the solution. That's the idea. Okay, we're dividing by 2.4. We move that decimal point one place over, move this one place over, straight up into the answer, add a 0 or 2, and away we go with the division. 24 into 6 won't go. 24 into 60 goes, let's see, maybe 2 times. 2 times 4, 8. 2 times 2, 4. Draw the line and subtract. 8 from 0 won't go. Borrow from the 6, it becomes 5. The one that we borrow makes that 10. 10 minus 8, 2. 5 minus 4, 1. Bring down the next digit, and away we go. 24 into 120 goes, I think 5 times. 5 times 4, 20, carry 2. 5 times 2, 10, and 2, 12. It goes evenly. Oh, happy day. So we get 0.25 as this quotient. We come back over here then. This is 0.25, but we want to express this as a percent, and the percent is 25%. So we are answering the question, 25% of 2.4 is 6/10. This next problem says 6 is what percent of 250? Notice that this problem is similar to the ones that we had before, except that the unknown percent is to the right of the verb, you see. But it's no matter. We just interpret what we see before us. 6 means is equal to. What percent? Some unknown quantity like n. Of means times 250. You see, we approach it exactly the same way. It's just the unknown is on the right. That doesn't make any difference. Our concept for solution is to isolate the letter regardless of which side of the equation it falls on. All right, we want to get rid of the 250. We could write this as 250n, or we can leave it just like it is. Our idea, though, is to divide on both sides by 250 in order to get a nice cancellation on the right and isolate that n. If we divide on the right by 250, though, we need to divide on the left by 250. So we show this. Now the 250s go out as expected. And on the right, we have n isolated. Now, 6 divided by 250, we would presumably go to the side and perform that division. Or, if we're using a calculator, we would punch 6 divided by 250 equals, and we would get a result. And the result turns out to be this decimal. Now we change the decimal to a percent in order to answer the question. Slide the decimal point 2 places over, and we have 2.4%. So the percent we're looking for is 2.4%, and now we can answer the question. We can say then that 6 is 2.4% of 250. Here's another, same idea. 5/10 is what percent of 40? 5/10 is equal to what percent of means times 40. We can write this as 40n, and then we look at it just a moment and we say, let's divide on both sides by 40. So we show that. We bring down the left side, divide by 40. Bring down the right side, divide by 40. The nice cancellation on the right results in an isolated n, which is what we're after. When we divide over here, well, gee, I don't see that division very easily. I might come out to the side and show the division like this. Once I have performed the division, and notice it's part of the problem here, and I'm real proud of this, and so I move the answer, the quotient, back into the equation format. I have my decimal here. Now I need to change the decimal to a percent, and I do that by sliding the decimal point 2 places to the right and tacking on a percent sign. So 1.25%. And now I've answered the question. I can now say that 5/10 is 1.25% of 40. A television survey of 4,000 families found that 2,500 liked a new TV show. What percent of the families liked the new TV show? It turns out that we can figure this out by a direct interpretation of the last sentence. We begin this way. What percent? Well, we'll let some letter stand for that percent. We'll say N is some percent. The word of, we know, means times, so we'll tack on a times sign. The families. Now let's see, the families in this survey, television survey of 4,000 families. So this must be 4,000. Liked. That's a verb. Well, the verb is usually replaced with an equal sign when we're changing an English sentence into a mathematical form. And the new TV show, the people that liked the new TV show, is 2,500 in the problem. Now we'll divide on both sides by 4,000, and after we divide on the right, we find that N is equal to 0.625. We change the decimal into a percent by moving the decimal point 2 places to the right and tacking on a percent sign, and we find that N is 62.5%. So 62.5% of the families like the new TV show. Now, I want to show you another way to request or to deal with the same problem. The problem might have been asked like this. It might have said, the families that liked the new show were what percent of the families surveyed? You see, the question could have been asked this way, but look at what happens if we do a direct interpretation. Even though it sounds a little bit different from the one before, it's really exactly the same mathematically. The families that liked the new show, well, how many liked the new show? 2,500. Were, a verb, equal sign. What percent? Well, that's the unknown amount. Some letter stands for the unknown amount, N. Of, that means times. And then the families surveyed. The number of families surveyed, well, that's 4,000. You see, so it turns out that we have exactly the same equation that we had before, only the right side was on the left side and the left side information was on the right side of that equal sign. It's just kind of backwards from the way that we had it before. But we would solve it exactly the same way and get exactly the same answer.